in the upper 50s. West winds 15 to 20 miles an hour with gusts up to 35 miles an hour. Friday night, mostly clear. Lows in the mid-30s. Northwest winds 15 to 20 miles an hour, diminishing to 5 to 10 miles an hour after midnight. Saturday, sunny. Highs in the upper 50s. Northwest winds 5 to 10 miles an hour, becoming southwest in the afternoon. Saturday night, mostly cloudy. Lows in the mid-40s. South winds 5 to 10 miles an hour. Sunday, mostly clear. Highs in the lower 60s. Monday, partly cloudy. Highs in the lower 60s. Lows in the mid-40s. Tuesday through Wednesday, showers likely. Highs in the upper 60s. Lows in the lower 50s. Chance of rain 70%. Thursday, mostly cloudy. Showers likely. Highs in the upper 60s. Lows in the upper 40s. Chance of rain 70%. Now for the National Weather Service marine forecast for the Chesapeake Bay from Sandy Point to North Beach. Tonight, southwest winds 15 to 20 knots with gusts to 40 knots, becoming northwest with gusts to 25 knots late. Waves 4 feet, subsiding to 2 to 3 feet after midnight. Showers likely with a chance of thunderstorms until midnight, then a chance of showers and thunderstorms after midnight. Visibility 1 nautical mile or less. Friday, west winds 15 to 20 knots with gusts to 35 knots. Waves 3 feet. Friday night, northwest winds 15 to 20 knots with gusts to 30 knots. Waves 3 feet. Saturday, northwest winds 10 to 15.
Alrighty guys, what is going on? And welcome back to another live stream. I hope you guys are doing good here. So, hope you guys have been staying safe and doing alright here. So, yeah, well that was fun. Trying to see if we could get some storm footage, but that obviously didn't work out earlier. But like I said, you guys, I hope y'all are doing good, and I hope you guys are having a wonderful day today. So, we have a little bit to talk about here. Like I said, hope y'all are doing good. Glad to see all of you guys here. So, we're going to go ahead and get right on into it. So, let's go ahead and switch on over here to our latest view. Obviously, that's a side wing of a B-52. There we go. That's better. That's a lot better. But anyways, guys, like I said, hope you're doing good and hope you guys are having a wonderful day today. Let's go and make sure that the live stream is actually running okay here. Okay, it sounds like we're doing okay. Just making sure, just seeing if we're doing actually okay here. But like I said, y'all, I hope y'all are having a wonderful day today, and we are currently looking at the current event that is kicking off here at the moment. We have a bit to talk about. Weather on the Go says, hey, you are back. I am back. And obviously our little attempted storm thing didn't really work out too well, but, you know, like I said before, you win some, you lose some, you can't win them all. But I'm just glad to be here for y'all. You know, like I said, you know, we're back here at the weather station, back here at the lab, I guess you would call it. Taking a look at what's going on here. We are still seeing some severe storms here kicking off at the moment. Abby says, I'm here. What's up, Abby? Welcome to the live stream. Weather on the Go says, hey, you're... Alright, I already said that. Welcome, you guys. Hope y'all are doing good, and I hope you guys have been staying safe here. But we're back, y'all, and we are seeing some storms getting ready to move their way into Philadelphia. Philadelphia, you better be on the lookout here. There's a nasty side of storms here moving your way. We got to watch this here pretty closely. And like I said, we are... yeah, we're starting to see a lot more severe storms here. So we have a severe thunderstorm warning that is in effect here for 11 more minutes. 60-mile-per-hour wind gusts and 3/4-inch size hail is expected. This does include bits of Westchester, bits of Norristown, Montgomeryville, as well as Lambertville, Clinton as well inside of this warning. This will expire here in 10 minutes, like I have been saying here, but that's what we are looking at here. Yeah, New Jersey, you better be on the lookout for this because there's a nasty set of storms. I mean, obviously, I cannot relate in that sentence. If you guys know exactly what I'm talking about, you know what I mean. Yeah, it was a pretty crazy event. Pretty sad event here that happened. You know, you guys might know my county here. What's going on over here now? Is there something else coming our way? Well, that's some low precipitation what's going on here. But it has like a weird little notch coming out of it. Let's go see. I'm trying to send you those photos. 22 Iowa. Can't find your username. So do at NWW1162. I said once again at NWW1162. What's going on over here though? I want to know what's... Switch velocity scan here. Obviously this is not velocity. There we go. Let's do storm relative velocity, because these storms are moving pretty quick. They could... Huh. Kind of seems like they are, yeah. It's kind of odd. So you can use some future videos. They're stunning photos. Well, anyways, yeah, feel free to send them. If you guys do want to send any photos and stuff like that, feel free to. Like I said, it's at NWW116, you guys, or at NWW162 here, to check it out. Okay. Well, apparently I'm still inside the slight risk area here. Let's see. Let's see how many warnings we have. 0 tornado warnings and 2 severe thunderstorm warnings. Okay. This is not as crazy as we saw yesterday, obviously. But it's still something here. We still have a severe threat level 2 out of 5 in effect. I also wanted to browse the models with y'all and look what's about to happen here in the future. We're going to look at the next potential here of the upcoming severe weather. I was going to see, Jonathan said I had a tornado watch. I was like, oh crap, but tornado watch is done by 6 p.m. Well, obviously, I think you're good. Looks like you're pretty good here. How much of a percentage for Union County? Abby, which state is that in? Is that for New Jersey, I believe? Not exactly sure. Okay, we're zooming in here. There's we need to watch out for possible tornadoes too. Like I said, tornadoes and large hail and damaging winds are going to be a pretty big concern for today, which we've already seen here. All right, I tell you what, y'all. Tell you what we're gonna do. Okay, for New Jersey, let me actually pull up Union. I need to figure out what county where it's at, because I mean New Jersey's pretty small. Oh, okay. This is pretty much right here. I think that's Union County here. Oh, you're about to get the line of storms here. So what was your question here? What is the percentage? I'd say 100%. I'd give it 100%. Just considering, you know, this line does not look like it's going to break up anytime soon, and it's moving directly towards you. Yeah, this is it's moving towards you. Oh, a new severe thunderstorm warning just now got issued. This does now include Philadelphia. Actually, I guess it's just an extension of the warning. So these areas here, a new... Okay, yeah, because this one's about to expire on the back end, so they just reissued another warning here. So yeah, we have a new warning out in place. It does include Philadelphia. Abby says, thank you. You're very, very welcome, Abby. You know, like once I said, guys, you know, sorry that the outside thing didn't really work out too well. You know, I thought we had it. I really did think we had it, but... You know, I guess not. I guess Mother Nature was like, nope, not today. Like I said, we have a whole season to go through, and we're going to be trying that again here. So, here we go. We're going to go ahead and switch on over here to the main screen, or onto our central screen here. We're going to take a look at the models. I do want to discuss in regard to when can we see our next event here. We'll take a look at the GFS model right now. See what's going on here, continental U.S., We're going to first off pull up and see if there's anything on the horizon. We're going to take a look at the instability in the atmosphere here. Obviously, we have what's going on right here. This is basically what's happening right now. Let's go ahead and pull up the pen view here. Let's go see your dumb part. Rachel. Let's go ahead and see here. I've got a bunch of comments coming in here now. Let's go see. Donna says, hey, we actually had a tornado warning in my area. Well, hope you stay safe. That is not the case anymore, it doesn't look like. Well, I'm still glad that you're right at like 6 p.m. Well, obviously, it's good you're here, for real. Plus, we have hurricane season. Yeah, that's going to be another thing to be pretty interesting. I love tracking hurricanes. That's just something I love doing. I mean, any type of storm, really. Severe weather events and hurricanes, like, severe thunderstorms and hurricanes, those are my two favorites to absolutely track. Those are the coolest ones. Snow I don't mind, but snow can be a lot more tricky. Believe it or not, snow is actually much more tricky to track here. Here we go. Looks like we got a new convective system coming on here with a new area of low pressure kind of driving down here. It kind of looks like from the north. Let's look more into this here. A lot of instability is at play here. Look at this. We're seeing instability values here in the 2000 mixed layer. That's a lot. That is a lot of energy here, but it does look like the wind shear is a bit of a concern. Let's see what the lower levels are doing here. Yeah, they're garbage. I don't think any tornado is going to be a concern out of that. I'm going to grab a sounding here. Let's go ahead and take a sounding here across western Mississippi. This is for April 5th. Okay, obviously we have a relatively dry mid-levels of the atmosphere here. My only concern here is that lower level wind profile. Right in here, this is what got me concerned here. The winds are pretty low, which is going to obviously throw off some development towards the surface. But I will say there is a lot of instability at play here. We have a lot of, basically from right here all the way down to the surface. This is all energy, and this goes up to around 12 kilometers. This goes actually pretty daggone high here. And we are actually seeing essentially, we are actually seeing a lot of energy in the atmosphere here for the 5th. So I could say the hail could be a concern here, just considering our mid-level dryness, as well as our decay values here pushing over 1,000. So honestly, that's actually that's enough to support some hail and damaging wind potential here, for sure. It's kind of what I am seeing here. Back in 2020, I had a horrible thunderstorm. It came through knocked out my power for 3 days. Wow, Abby, that's crazy. You have northern stream, or you have a northern stream, or northern stream shortwave. Okay, shortwave trough here. Southern stream shortwave possibility come together. Those types of setups are always difficult to predict because of the phasings with issues with energy. Well, I mean, what's showing right now, obviously you can't look at one model here. We're going to take a look at the, I guess, on this view, ECMWF isn't a thing here for mixed layer. Now, this has been trending here over the last few days. We get that Gulf advection going on here. Kind of, you can see those wind barbs here move their way here to the west. You can see these little wind barbs right now move to the west. Eventually, this will, as we do progress here into the mid portions here of the 4th, you're going to start to see that wind direction start to kind of push up here to the north here. So we're getting that bit of a upper kick here between your wind direction. When are we getting more rain here in Dallas-Fort Worth? We'll discuss that here in a second. It's kind of what we are talking about here at the moment. So there's obviously a lot of instability at play here. I mean, over 1,000 joules per kilogram. But the problem is there is a lot of cap here involved as well. Wind shear is a bit weak. That's what I'm having issues with. Obviously, if you look at 925, we're seeing knots here, or we're just seeing under 20 knots. I don't think tornadoes are going to be a concern here. It is pretty far out to tell. I mean, this is literally just a few days down the line, but you'd be surprised of how much can change here within that. Yeah, look at this. So this is kind of showing what's happening here. It's actually more of a. No, that's a connected trough. I think that's more of a. That's a weird kind of tilt right here. It's kind of a large dip in the jet stream, but it's not as sharp as a lot of these other events. I mean, sometimes you see like the jet stream do something like this. That's when you get those bad events because you get all that warm air driving its way up to the north. And the problem is that this trough is essentially kind of off its axis here. Because instead of more northerlies, it's more northeasterlies, which, we'll see what happens here. We'll see exactly what happens here. It's still pouring rain here. Donna, stay safe. We're going to be here for y'all. But yeah, honestly, it's something we should watch out for, honestly. I mean, there is a lot of instability in the atmosphere here. I mean, look at this, especially for pretty much evening hours here, like afternoon, evening hours here on the 5th. There's a lot of energy at play here. I'll tell you what, let's go ahead and switch to float 2 here. A lot of energy we're seeing in the atmosphere, well more than enough. We're going to grab another sounding here across eastern Louisiana. We're going to see what's happening here. Okay, this shows, even though this shows tornado, don't get that mixed up here. I really don't think a tornado is going to be a major concern here. Like I said, the lower levels is kind of a bit trash here. I mean, look at this. We're seeing these lower to mid-level wind shear is pretty weak. I mean, we're talking 20, 30 knots here. Yeah. The speed of the shortwave and how these phases or don't phase will mean everything when it comes to severe weather. We just gotta watch this and see what it does here. Obviously, it looks like wind shear is going to be a concern. Not much wind shear. I mean, the mid levels to the upper levels are good. They obviously have their wind shear. There is a slight varying wind shear pattern, but it's more of northeasterlies and northerlies here. It's more of like a speed shear thing instead of a directional shear issue. Because you see the winds are pointing in the same direction from your surface to your upper levels. But the problem is just how low our wind shear here is. I mean, typically you want to see that over 40 knots. Your wind shear over 40 knots here towards the surface for tornadoes. And it's better to have northerlies at the surface and northeasterlies at the mid-levels to upper levels. That's what you want to see, but I'm not seeing it here. Obviously, I don't think tornadoes are going to be a big concern, but I will say there is a relatively dry atmosphere. There's a big gap here. Obviously, some upper-level saturation going on between your dew points and your dry bulb. But, what we're seeing here is essentially, dry atmosphere. Basically, the more spaced out your red, basically your outside temperatures at a certain level, and your dew points here in the green. The more spaced out they are, the more dry the atmosphere is, essentially here. Now, that could favor some hail in itself. That's if the updraft can support it. Which, precipitable water here, I mean, it's around 1.5. That's basically, how much. It's kind of hard to explain what this means, but the higher the value, the more weight is being pushed down on your incoming fuel, your storm's updraft. That's not good for hail development. Now, you want that value to be much lower for hail development because it allows a lot more, it's a lot more lighter on the updraft, which allows for the updraft speed or your vertical velocity to get higher. I think the hail will be a concern here. I don't think a tornado would be really a concern. I think hail will be a concern, as well as maybe some damaging winds that maybe over 60, maybe up to 70 miles per hour being a concern here for the 5th. I do believe the storms will fire off, but I don't think that they will be long-lived. I think they'll be pretty relatively short-lived. And I also believe that tornadoes won't be a concern. I mean, like I said, we're looking here. Like I said, we get all this advection, but instead of that winds continue to track to the north, they become quickly shifted to the east here. Just considering how what kind of angle of attack this trough has here. Like I said, once all that instability is in play here, all of our lower level energy here. I mean, look at this. Here is towards the surface. Actually, I'll go ahead and show you something. Kind of what we're talking about here. We'll go ahead and grab our values here. We're going to roughly draw where all this instability is in play here. Obviously, like I said, you can't trust that exactly. Then we're going to draw a line here. So obviously, this is where our weaker shear is. I mean, we're talking over here. We'll actually go ahead and mark this here. We're kind of roughly talking about, honestly, 20 to 30 knots at 925. So at 20 to 30 knots at 925, obviously our highest shears on this edge here. More northeasterly at 40 knots. This is mostly just 40 knots. Now, what happens is whenever you go up in the atmosphere here, now we're looking at the mid-levels, it's still the same direction here. So it's still pointing to the northeast. So there's not much of that veering wind shear that we usually see during these events here. I'd say a slight to maybe enhanced risk would cover it, but broken light. You can't even say that right now, honestly. Okay, so what we know from this sounding, or from multiple sounding sources, as well as what the models are showing here, is essentially that hail and damaging winds are going to be a concern here for the 5th. I'll tell you what, though, we're going to switch to the 18Z. Apparently that wasn't even the latest model here. Okay. Now, latest model shows a bit of an increase. Okay, that's a lot more. Wait, okay, never mind. Okay. Yeah, so there we go. Maybe a little bit more of an increase in that lower level compared to what the latest GFS had to say. Obviously, it's still trending that high instability, favorable environment here for the 5th. So the 5th is kind of what we're locked on here. Like I said, a lot of the energy is kind of around here. It covers much of the southeast. It does cover much of the southeast here. All that thunderstorm potential. But like I said, that lower level energy is kind of my concern here. This is pretty weak. So I don't think tornadoes is going to be a concern. If anything, lowest potential, no big tornadoes, no. Obviously, I can't tell you exactly. I can't tell you exactly what we're seeing here, but because essentially these models can still change this far out. But we're going to pay attention to this. We're going to watch this over the next few days. I just think that hail and damaging winds is going to be a concern here. There's that main line of the trough. But all the atmosphere is all the instability is kind of bled out there, though. That's the thing. I know I can't say that, but looking on analog similar events, how they play out, which favor to loosely organized MCS. Well, I'm worried about those lower levels here. So I kind of want to explain what a sounding shows here. Now I know they look kind of creepy, and they, honestly, they are. They're not as difficult to read as they look. Don't take it all in at once. We're just going to pay attention to this side of the graph, okay? We're just paying attention to this here. So scribble all this out. We're not looking at this. We're not looking at any of this stuff right now, okay? This is what we're looking at here. So we're going to change our pen here to a different color. So this right here, this is at the surface, basically at the lower levels of the atmosphere. This is at the mid levels, so this is around 8 kilometers in the atmosphere. And then this is your upper levels. So your surface, your mid levels, and your upper levels here. So, this is also kind of considered your transition between between your mid levels here. Not Zach says, "Hey, how's it going? What's up? Welcome to the live stream here." But we're kind of looking at this side of the sounding here right now. So for tornadoes, you want to have your winds blowing to the north here towards the surface. Usually, obviously you can still have them without that, but the big winds that we have been seeing, like the one we just had, you see that northerly and then that northeasterly turn, because that wind direction turns as you go up in the atmosphere. That's not the case. Now you see what the problem is with this is that we have some very weak shear. Basically, the winds are moving pretty slow. Okay, we're talking about 20 knots or so towards the surface. That's very weak shear. For tornadoes, here towards the surface, you want to have your winds at around 40 knots and higher, honestly. You can have a weak tornado at about 30 knots, but anything lower than that's kind of a bit sketchy here. Now, as you go up in the atmosphere, right here, starting towards the mid levels to the upper levels of the atmosphere, like I said, we're talking about. This is basically showing, there's a lot of fast moving winds here. That's good. So as our updraft, that big old cumulus cloud starts to rise here, it's going to start to shift more further to the east. Right here, kind of show you what I'm talking about here. So, as your thunderstorm starts to, because thunderstorm starts as a cloud and they rise, it gets taller, it gets higher and higher. Now, since our shear is pretty weak, our cloud base is going to remain mostly vertical, considering how weak the wind shear is here. And as we go up in the atmosphere, it starts to get more strong. So that's good news, because our atmosphere, we have all that warm air driving its way up into the colder atmosphere above. And like I said, what goes up must come down, and so it's going to continue to move up until it reaches the EL line right here. And it's going to start falling. That air is going to start falling here, back at the ground. So this is your downdraft. This is your updraft. So all that warm air comes up, and the cold environment condenses once it reaches that cold air, and it goes up to this height because this is right here where the instability ends, right there. I know you guys aren't understanding anything I'm saying right now, but I'm just kind of showing you some people, kind of what I'm talking about. But essentially that's how these things happen. Like I said, these storms they work very similar to an engine. You need an intake and you have an exhaust, right? So obviously there's a huge gradient in energy between cold and warm air, right? Obviously, during the winter times, everything gets cold, and from the surface, even well all the way up in the atmosphere, it gets very, very cold. Now, once spring hits and the surface starts heating up, just remember the atmosphere above is, that takes longer to warm up than it does at the surface. So that essentially warms up. And if you get a cold front moving through, it's going to bring all that warm air to the surface into that cold air environment. There goes my camera here for the first time tonight. Now, does that kind of make sense for you guys? I'm pretty sure people are probably scratching their heads, wondering exactly what I'm talking about, what I'm ranting about here. Come on, camera. My camera is glitching out here. Okay. Well, I guess my camera does not want to load here. Okay, there we go, finally. Okay. Abby says there's lightning. Stay safe, Abby. Natsai says, yeah, great exclamation. Thank you. Okay. So, like I said, I kind of want to draw something for you. We're going to bring out something pretty interesting here. I've never done this at least I don't think so, on this channel. We're going to pull up the trusty old program here. Everyone knows and loves. I'm gonna kind of explain what's happening here, okay? We're gonna make this huge. All right. So we're gonna draw on screen here. So, like I said, how these things work here. You have your surface. Basically, right here at the ground. This is your surface. This is your mid levels of the atmosphere, and this is your upper levels. That's how these soundings work here. Heat lightning does not exist. That's true. Lightning is lightning. So, like I said, as winter happens, obviously it's very, very cold here on the ground where the surface is. It gets very, very cold here. And it also does get cold here in the upper portions of the atmosphere as well. Now, like I said, when spring hits, these areas here are still very, very cold. But these areas start getting warm. Okay? So what happens is essentially, once all of that warm air gets lifted up into that colder environment, all that warm air here, it condenses. I'm sure you've heard of that before. It condenses, it turns from water vapor into actual, condensation, actual precipitation here. Put some grass underneath. Okay. Yeah, I feel like I can draw that a little bit better here. I'll tell you what, we're going to make this look very, very nice here. I wish I had a better view where my camera and stuff wasn't in the way. But here we go. So I'm actually going to use the thing here. I'm trying to explain this the best I can, and we're gonna try our best here. Okay, there's our ground. I feel like I made our ground too big, but actually, yeah, I did make our ground too big. We're gonna redo this here real quick. Okay, we're gonna make our ground like that down here. That's better. Okay. We're gonna fill in our grass here. So that's our surface right here. We're gonna make the okay, that's a lot better. That looks a lot better here. Lightning struck ground. Obviously, stay safe here. Stay safe, you guys. Okay, so I'm gonna explain to you what's happening with this event here. essentially, what's going on here. So we're going to take a look here back into models real quick. So obviously, like I said, there's a lot of instability. So there's a lot of interaction between that warm and cold air. Let's go ahead and fix my camera again. Man, this thing absolutely loves to die on us here. Okay, we're back. Okay. So we're going to take a sounding here. George says it's raining so hard. Stay safe, George. We're going to be here for you. Okay, so like I said here, this is actually a pretty good representation. I'm actually going to, I'll tell you what, I have a good idea here. I have a good idea. Okay, we're going to highlight this. I'm going to redo that, actually. I'm going to include the little wind barbs here, too. Okay. You're about to see what we're going to do here. Okay. Okay, bring up our paint thing here. We're getting there. Hang tight, y'all. We got this. Okay, let me go ahead and find my thing. I'm gonna add this to our little fancy thing here. So we're gonna get the real deal going on here. I'm gonna try to explain this the best I can. And like I said, I know some. There we go. Okay. Wait, can I not add? Hey, okay, that works. I wish this wasn't this glitchy. Here, let's do this. Okay. We're gonna do this. Oh, that's not good. Okay, we'll just have to deal with that. Go ahead and grab our little sounding here. All right, I think we're set. I think we are set here. Yes. Okay. Perfect. I think we're ready to explain this. Okay. So I'm going to show you what's going on inside these soundings. This is the only side we got to look at. This is all we're caring about. Let's go ahead and get rid of that too. We're doing live weather school, y'all. Let me know if you guys would actually like to see me do like educational videos, like stuff like this, to kind of explain, you know, what's happening in the atmosphere. Okay, so first of all, we're going to grab our little thing here, and I'm going to explain what's going on here. So this is basically our thermodynamic look here. Okay, I know you guys don't know what that means. Basically just interaction of temperatures. Okay, so like I said before, right here, this is the ground. You know, this is at the surface. This is around the mid portion of the atmosphere. So we're talking about maybe up to 6 kilometers or so. Okay, and now we move up a little bit higher. This is the upper levels of the atmosphere. Kind of similar to what we're seeing right here, okay? So here's our upper level. Here's our mid-level. And here's the ground, the surface. Got it? Okay, cool. So, essentially, we have a few lines here, obviously you can tell. Ignore this dotted blue line here for now. Ignore this blue line here as well. Just look at the red line and look at the green line. So essentially, it's hard to see, but basically what this is showing is the red is showing our outside temperature. Simple as that, across the entire levels of the atmosphere here. Let's go and see here. Any warnings for Union County? No, you're good. Anyways, okay. So like I said, that's what we're looking at here right now. So basically, the red is showing our outside temperature at a certain height in the atmosphere. Like I said, mid-level of the atmosphere, here's your temperature. Surface, there's your temperature. It's kind of hard to see, but it goes diagonal here. Okay, because it's kind of tilted. The axis or the graph is tilted here. So, but this is your temperature line here. So this is what we're looking at here. Okay, so essentially what happens is between your red line here, your outside temperature, and this blue dotted line, between this is all energy. This is that mixed layer cape. That's that convective energy we're talking about. So if the red line is on the left-hand side of this blue dotted line, there's energy in the atmosphere for thunderstorms. Now, if it's on the other side, if the red line's over here, there's not any. There's no energy. It's actually, probably a very nice day outside. I'm trying to explain this here the best I can. So, essentially, let's go see. Abby says, "Happy birthday, Andrew." Thank you so much. My birthday is here in 2 days now, April 2nd. Can't believe I'm going to be turning 20 here. So, all right. So essentially, like I said, so between your red line and your blue dotted line here, if your red line's on the left-hand side, you have energy in the atmosphere here. So what we're seeing is that, we're seeing energy here all the way from the surface to this level here. And then you see that red line cross on the right-hand side. So that's how much energy, that's where all the energy's at. So that's how high the thunderstorm will go. Okay? If we line that up, that's probably around 10 kilometers or so. There goes my camera here. Let's go ahead and get that back up here. So that's how you determine storm height, according to a sounding. Okay, so that's, the equilibrium level, or the EL. You see a little EL here. This is how high your storm top is going to be. That one says, did I go to college? You're probably gonna have a hard time believing me, but not yet. But I have studied meteorology for many years, and I've talked to many meteorologists about all this stuff. You could say I know a few things about weather here. All right, so like I said, this is about how high the storm will be, because like I said, once your red line, your outside temperature is past this blue line here, on the right side, this is all positive energy, so stability, stable conditions here. For thunderstorms, you need instability. So if your line's here, if your outside temperature is on the left-hand side of this blue dotted line, that's instability, okay? Now, that's what we're talking about here. So that's how you measure, what part of the atmosphere has energy. So we have instability all the way from the surface all the way up here to the equilibrium level. So that's about, like I said, 10 kilometers or so in regard to things here. So that's what we're looking at here. Okay, we're actually we're gonna move that back here. Okay. I hope that made somewhat sense. Like I said, it's kind of a bit tricky to explain some things, because I'm trying not to go too far, but it's kind of hard not to, because once you understand a lot of these dynamics, it'll just click. It'll click. That's what it did to me. I learned a whole bunch of side things. First, I started off with learning how to read radar, and then I moved into these soundings and stuff like that. So like I said, this is at the surface, this is at the mid-levels of the atmosphere, this is at the upper levels of the atmosphere. That's what we're looking at here at the moment. So now, like I said, between your red, your outside temperature, and your dew point being here in the green, the further the distance they are spread apart, the more drier the air is. And for dry air, that supports some hail. Especially across the mid-levels of the atmosphere here. What this sounding is telling me is essentially there is a lot of dry air here across, between your mid-levels of the atmosphere and towards the surface. So that's showing some ice growth. That's showing some crystal growth here. That's showing some, hail growth and potential hail problems. Okay, relatively dry atmosphere towards the mid-levels. That's seriously, that's a big potential for ice here. So for some hail growth. So that's what we look out for. That's going to show me that there's going to be some hail. Like I said, that dry atmosphere here, as well as you can see, like I was showing before, the energy. Your red line's on the left side of this line, the blue dotted line, like I was telling you. So this is all instability. This is all energy that's needed for thunderstorms. Between, your red and your blue, the further they are apart, the more energy there is. Closer they are, the less energy there is. Considering how far these are apart, that's a lot of energy in the atmosphere around that level. So we have a relatively dry atmosphere here. Like I said, our dew point temperature indicated in green, and our outside temperature, our dry bulb, your ambient temperature, is spaced out. So that's showing essentially it's dry air. Now, you guessed it, if your red and your green lines are touching, that's where condensation, that's where condensing, that's where a cloud would be, that's where rain would fall. Okay? So hopefully that makes somewhat of sense here. Let's go ahead and see here, just asking because I think it's a waste of time. Honestly, it's a waste of money too, for real. It really is. And, I think, I'm very, very strong with what Elon Musk says. about the fact that you don't need college. Just, you can learn anything you want to online, essentially. You just got to have dedication. And I've had dedication. I've been studying this stuff for many years. I have been so dedicated. Whenever people would come home, your normal kid would come home and play video games, I would be that one guy who would come home and look at weather stuff and learn things about weather here. So, yeah, that's essentially how I got into it. And I just kept on building information. I just kept on learning and, plotting it down, wrote some notes and stuff like that, and just... I'm glad to see where I am right now. Obviously, I'm still learning. I'm not perfect, but I know more than the average folk, I guess you could say. So like I said, the further distance, between your red line here and your green line, that's showing us that the atmosphere is pretty dry. Considering our outside temperature and our dew point are far apart, that would also mean that the relative humidity is lower. The higher the humidity, the more closer your dew point and your outside temperature are to each other. I want you guys to remember that. Higher the humidity, the closer your dew point and your outside temperature are. The further they are apart, the lower the humidity. So we can see that there's lower humidity here, less water vapor in the atmosphere, so it's pretty dry across that level. So this allows for hail growth to occur, and especially, like I said, between the blue dotted line here and our red line, if our red line's on the left side of the blue dotted line, that is energy. That is where energy is for thunderstorms. And if our red line's on the other side, as we do see well up here in the atmosphere, the upper portion of the atmosphere, how it crosses on the right side, that's showing stable conditions. That's where, no more growth of thunderstorms would develop. So we can see, that crosses right there at that intersection point, right kind of between where it goes from the instability to the stability here. It crosses the line right there at that point. That's what we call the equilibrium level. That's how high your thunderstorm top would be. Also known, as we look at radar view, that would be indicated by echo tops. Now, obviously, your cloud is a lot higher, a little bit higher than your echo tops are on radar, because the radar cannot detect clouds. They detect the water droplets inside the clouds. And obviously, at the top of the cloud, where, it kind of thins out a bit, there's a little bit, not as crazy condensation going on there. But yeah, that's what we are dealing with here. Let's see, disagree on that part. I want to see if pays more. Where association allows scientific language over time. I used to play No Weather Radio 24/7. I did too. I love how interactive you are. It's awesome. I wish you had the best thing. Thank you so much. Greatly appreciated. Let's go and see here. Niece says, I live in Sanford, Florida. Should I be worried? So, southern Florida has a marginal threat, or central portion of Florida has a marginal threat. Lowest and severe threat. I think it'll be all right. The greatest thing is, obviously the... what's going on here is, the majority of the severe weather events are already pretty much over with now. There's still a bit going off here in the northeast, but it'll be out here later on tonight, for the most part. All right, so back like I was saying here. So I hope you guys kind of understand what I'm talking about here. This is towards the surface. This is right here at the ground here. This is the mid portion of the atmosphere, about 5 to 9 kilometers up, I'd say. Just mid levels of the atmosphere. And the upper level of the atmosphere, we're talking over 10 kilometers, okay? So that's kind of what we're talking about here. So right here at the mid-levels, there's some dry air. Like I said, the green here is representing your dew point. The red is showing your outside temperature at that level of the atmosphere here. And I'm going to go ahead and do this again. The further your red is away from your green, the more drier the air is, the lower the relative humidity is. Basically, the drier the air is. So we are seeing here that since we have our reds and greens so spaced out here, there is a dry atmosphere across the mid-level. That's what we're dealing with here. So dry air across the mid-level, which that can support some hail. Now, as we go up in the atmosphere here, you can see that our red and our green intersect. That's where a cloud would be. That is because, that's where condensing starts to occur. Once your dew point and once your outside temperature meet each other, relative humidity gets to 100%. The atmosphere cannot hold any more water vapor, so it condenses from gas into liquid once your dew point and your outside temperature meet each other. So this is well up in the atmosphere here, and that's what we're dealing with here. So like I said, if your red temperature, or if your the red line here, your temperature is on the left hand side of this dotted blue line here, That's instability in atmosphere. We can actually see that it's on the left-hand side, all the way from the surface, way up in the atmosphere to the upper levels here, stopping right here where it crosses from the left-hand side to the right-hand side. So that's where stable air comes in. This is where unstable air is. Okay, so we have a lot of energy here from the surface all the way up. So, like I said, you've probably seen thunderstorms before they started. They start off as a cloud, a cumulus cloud, and they start to rise. They get bigger and bigger, and you see these big old towers starting to form. That's basically that cloud that's growing vertical into that colder, that colder atmosphere here. So that's essentially what we're talking about here. Let's go ahead and see here. Let's go and try to get this. So Andrew, I can help him out with severe weather forecast all season. I really don't know as well. I'm studying meteorology. That's cool. Weather on the go. Yeah, if you want to help out. I'm getting an exclamation. Good job, Andrew. Thank you so much. Seems drier helps hail shaft. Drier cools faster. Essentially, yes. Like I said, if your air is more saturated, if you have a lot more water vapor, obviously water takes a lot more time to heat up and cool down. It holds heat. It takes a lot more time to heat up and cool down than dry air does, essentially. So if your hail is there, what does that tell you? I mean, obviously, it's pretty explanatory here. Let's go see. That's why I was going to see here. Yeah, okay, I'm getting it. That's good. Hope you guys are getting it here. I really learned a lot from the channel. Andrew explains the way you can all understand. Thank you so much, Jenny. I try to be I can try to explain it as best as I can here. Yeah, that's what we were doing. Matt says I always want to see a water spout. They're pretty crazy. I've never seen one in person, but I've seen the better thing, the tornado. Okay, so that's what we just talked about here. So what we can tell from the sounding here is that we have a dry atmosphere here towards the mid-levels of the surface, which can support some hail because, like I said, dry air essentially, takes less time to cool down or heat up than saturated air. So this would take a lot more longer to heat up and cool down than it will down here, because it's more, more saturated here. So like I said, if your red and your greens, your outside temperature being red and your green touch each other, that's where saturation occurs. That's where a cloud will be condensed. And since we're so far apart from here to here, basically from your outside temperature to your green, this is basically showing you that we have a dry atmosphere. So I'm glad you all get that here. Okay? So then we have another line here. I'm going to try to explain this. This has always been kind of a problem for me, so I want you guys to listen closely on this. So you notice that there's a line between your green and your red. This is what we call the wet bulb temperature. Now, a good explanation on how I can explain wet bulb, it's evaporative cooling. Okay, now you guys probably are wondering, what the heck did I just say? I have a good example of how this is. So I'm sure we've all been swimming. If you guys have been in a pool before, have your clothes on, you have your swimming trunks on, you've been swimming before. Have you ever noticed how once you got in the pool and once you got out of the pool, how cold it is, essentially? And especially how cold it is whenever that wind hits you. That's basically measuring the temperature of how cold that is. It's kind of hard to explain, but I hope that makes sense to you. I hope that makes sense. So, like I said, your swimming trunks cool down very quickly. And they get very, very cold, even to the touch, because of, the wet there. So, essentially, that's kind of what this is showing here. Now, what you want to look for is essentially, you want to see that, you want to see that line here cross the freezing point. So, this line right here, this slash line you can see, this is all below freezing. All over here, below freezing here, this is above freezing. Okay, so this is your 0 degrees Celsius mark here. It goes sideways. It goes sideways here. So this is your freezing line. Okay, you can see at this level of the atmosphere, this is right where the freezing point hits. Does that make sense? Hopefully that makes sense to you. And then this line over here would be 10 degrees Celsius. This would be 20 degrees Celsius. This would be negative 10 degrees Celsius. And this would be negative 20 degrees Celsius. So this 0 degrees Celsius line, 32 Fahrenheit, is your freezing line across the atmosphere. Let me go ahead and get my camera fixed back up here again. Okay. So that's what we're dealing with there. So this is all below freezing. This whole side is below freezing temperatures. This is all above freezing temperatures, because that's where that line intersects here. Go ahead and get rid of all that. So that's what we're talking about here. So you want this line, you want your wet bulb temperature to hit that freezing point right here, where it intersects here. You want it to hit that freezing line once it reaches this level of the atmosphere. This is 700 millibars. Now we measure, height and pressure here. Did I know that fire tornadoes are a real thing? LO is crazy. I do. Yeah, for sure. They are pretty crazy. They're more common across the West. Okay. So we got all that down. That's basically that's what we look for. Temperatures here in the red. Outside temperature here. This is at below. Oh, I could have drawn that way better. Man, I could draw this. Okay, I gotta take this one slow here. Okay. This is all below freezing, so we see our freezing point hit the atmosphere right above this height here, which obviously it doesn't show height, but usually it shows what height this is on the left-hand side. So that's how high the freezing point is. Obviously, at wintertime, where it gets colder, this line's going to drop. Okay? So that's how that happens here. That's crazy here. What are these weather reports coming from? What do you mean, like the weather radio here? This one's here in Northern Virginia here. I don't know if that's what you're talking about or not. But anyways, guys, we covered the whole thing there. That's good. Now, you might notice this right-hand column here. What is all this? This is actually our wind shear. Now, wind shear, it sounds creepier than it is. Wind shear is simply wind speed and wind direction at a certain height in the atmosphere. Like I said, here at the surface, here at the mid-levels, here at those upper levels here. Okay? So, what we're going to learn about is a thing called a wind barb. Now, you've seen these many times on my channel here. So, we're going to do something here. I'm going to make a compass. So, this is north. This is south. This is east. And this is west. I'm going to try to explain this the best I can here. This is basically showing your winds now. Okay, so now we're going to talk about these winds here. So, you've seen these wind barbs on my channel before many times, I'm sure, but you probably don't know what they mean. I'm going to explain that right now. So now we're looking at wind barbs here. So, essentially, you would see a wind barb, so we're going to draw a little line right here, and we're going to see something like that. So, this is the wind barb right here. Actually, I should probably draw that in a different color here. Let's do, like, something like this. We're drawing our wind barb. So, actually, let's do this. Okay. So, this is our, right here, this is our wind barb. So, what this is saying here is that the wind is moving to the northeast at 5 knots. Now, there's a line that's taller than this, like kind of like that, but that's not a real scenario here. It would actually be something like that. Okay. So, the longer line here, the longer straight line is showing 10 knots, which is about 12 miles per hour, I'm pretty sure. 11, 12 miles per hour. So a knot is smaller than a miles per hour here. So that half line would be 5 miles per hour, or 5 knots here. So if you add these two up together, 15 knots, which is about 17, 18 miles per hour. You can do a conversion if you want to. But I've gotten to the point where, I don't know, like, knots, their exact conversion, but I have an idea. It's not too far away from miles per hour. Obviously, the higher you go up, though, the more separated they become. But at a low number like that, they're not really like that. So, let's go see here. Yes, I am in a particular state. Yeah, Virginia here. But obviously, there's not much going on in Virginia anymore, sadly. Okay, so that's what we're talking about. So we see, these are little wind barbs. You can see them right here in the corner. So we have some wind barbs moving this way. We have some wind barbs moving this way. So this is pointing in the direction the wind's blowing here. At this level of the atmosphere, like we were saying, height goes up with, how high, the top part, upper level of the atmosphere, right here at the surface. So this is around the mid-levels, and we're seeing that as pointing to the northeast. This, take this north, south, west, and east. Okay, I can't draw an east there, but this is pointing to the east, generally mostly to the east here. Now, like I said, follow what they have to say. So this is having 4 long lines. So it's looking something... Let's see. So it's kind of looking something like this. It's looking something like that. So we can look right here, pointing to the northeast. So the winds are coming from here, point A, to point B. They're going in this direction. Okay? So point A over here, point B over here. So that is how we can tell which way the wind is blowing here. So that is our wind barb here. Now, you might be thinking, okay, well, this is 40 knots because you have 4 long lines here. This would be 45 knots because it's a half line here. So 45 knots would be that. Now, you might be thinking, well, 50 knots would be this, right? No. There's actually another thing that they measure for 50 knots. Since the wind speeds can get well over 50 knots and into near 200 knots at some points, 200 knots would be well past this line. It would go on forever. So essentially what they did is this is how you measure 50 knots. You'll see a little half triangle, or actually no, this still is a triangle here. It still has 3 points. So this is what you would see for 50 knots. So 50 knots, 60 knots, another long line, 65 knots, a half a line. 65 knots, you can compare that to miles per hour or whatever you want to do. 65 knots, about 60 to 70 miles per hour here. So that's what we're looking at here. Question, is there a tornado in an area? Because I'm on the eastern Long Island here. There is, right now there's no active severe thunderstorm warning or tornado warning. If there was, we would be talking about that right now. But right now there's not. But yeah, that's what we're talking about here. It's going to see, a knot is half a meter per second, right? You have to do the conversion yourself. You can literally just look up miles per hour to knot, or knots to miles per hour, or knots to meters per second, whatever. But yeah, so that's essentially how you read wind barbs here. So, and obviously as you go up in the atmosphere, the faster the winds move, usually. The faster the winds move. So what we're seeing here is at the surface, we have a little wind barb here pointing to the northeast. So here at the surface, we have a little wind barb moving to the northeast. Remember, this is pointing to the northeast here, and it has 1 long line. So this is saying northeast at 10 knots. Now, if we go up towards the middle portion of the atmosphere right here, this has it a little bit more further arced here. So it's more northeast than east compared to the one down below. And this one shows it moving at 65 knots. So 50 knots, 60 knots, 65 knots. So you can see the wind speed increases with height and also changes more to the northeast, or basically more to the north. So then we go to the upper levels of the atmosphere, well up here. This one's showing 60 knots. So actually the wind speed drops down a bit, but still pointing in the same direction here. So 60 knots. So you guys kind of see what they're saying? You know, this is pointing to the northeast, still pointing to the northeast. So whenever you have what we're seeing here, so essentially what's happening right here is all the winds is pointing at the same direction here, from the surface to the upper level of the atmosphere. There goes my camera again. This thing absolutely loves to keep on crashing on me. It's been doing it a lot lately. Okay. So, that's essentially how you read that. Now, for big tornado days, what you want to see at the surface is the winds pointing to the north. The best option here is the wind bar pointing to the north here. I'd say, 50 plus knots is good right here at the surface, around 925. So you want to see it go to the north here, pointing to the north here towards the surface. And as you go up in the atmosphere for these big tornado days, towards the mid-levels of the atmosphere, you want to see this wind direction change here to the northeast. You want to see it go from the north to the northeast, so you kind of get some spin kicking off in the atmosphere. You've heard me say that before. And usually once you go up in the atmosphere, usually the wind speed does increase a bit. So we'll go ahead and say 65 knots here. So you can see the wind starts out at the surface here, towards the ground, at 50 knots, going to the north here. And as you go up in the atmosphere, it turns from the north to the northeast. So essentially, it shows the directional change. So that's for big tornado days. And then we have a hodograph. We're going to discuss that in another live stream. Right now we're just paying attention to the, the skew T chart. Let's go ahead and see here. Andre says, how's it going? Doing pretty good. How about you? Hope you're doing good. So, like I said, that's usually how it goes here. And then usually sometimes we'll have those well upper level winds. I mean, you can even see them do something like this. The most I've seen on a wind bar was like 210 knots. Believe it or not, it does happen. That's 210 knots of wind shear. That's moving quick. So, what we learned here is that on here, this basically determines direction. You know, which way they're pointing here. The point that doesn't have the notches, that's showing where the wind's going to. And like we said before, if it's a triangle here, that's 50 knots. If it's a long line, that's 10 knots. If it's one line or half line, 5 knots. But yeah, that's what we are seeing here. Storm's past me, now I'm good. All right, well, that's good to hear, Abby. I'm glad to see that you're okay. But I hope that guys made sense to you. Let me know if it did. I tried to explain pretty much as best as I could. I might make an additional video to this eventually, explaining what these mean. Hopefully that helped you guys out. Hopefully that helped you out. Like I said, we were just kind of looking at, you know, what we look on these soundings for. So since if you guys are still here, and compared to what we learned, let's take a look at the actual sounding here, shall we? So we went off this one. So let's go ahead and move down here a few hours. Let's just go back a little bit. Different sounding. All right, let's grab one across central Arkansas. Hold it down. So what the weather balloons show is what we just looked at as well. Weather balloons, I'm sure you heard of them. They look just like this on the left-hand side. They look just like this here. Andre says, I've been doing good. Just figured to stop real quick. Congrats on the insane growth of your channel recently. Thank you so much, Andre. Greatly appreciated. But yeah, so that's what we're looking at, you guys. So here's the sounding. So what can you guys tell me from the sounding here? I'm going to give you a second to think about it. Compared to what we just saw here, I'm going to give you a hint here. So here's the winds. This is the surface. This is the mid-level of the atmosphere. This is the upper level of the atmosphere. So this is next week. This is for the 5th of April. This is what we're watching here next. This is what we were looking at next. So, okay, we're going to go ahead and talk about this. Starting off with our wind profile. This is usually what I look at first when I look at... Or actually, no, that's wrong. I usually look at that second. So, first of all, we look at our temperatures. Like I said, our dew point here in green. Our outside temperature here in the red. Our 0 degree line, you can see right here, 0 degrees Celsius. 10 degrees Celsius. So this is our freezing point right here. That line right there, y'all, is our freezing point. So all this is below freezing over here. This is all above freezing. So remember, mid-level of the atmosphere, upper level of the atmosphere, surface. So since our temperature here is on the left-hand side of this blue dotted line here, this is showing that we have energy in the atmosphere. And we have that all the way from the surface, all the way up here to this point right there. Which this is just under 12 kilometers. You can do the measurement in whatever you want to look at. So that's how high thunderstorms will get. Just a little bit smaller than 12 kilometers. So that's how we determine on how tall these storms will be, according to the sounding here. There you go. We have a dry atmosphere in place here. You can see right here, right across the mid-level. So we have a pretty big gap between our dew point here and our outside temperature. So that's showing we have a pretty dry atmosphere across the mid-level of the atmosphere that might support some hail. Obviously, the further they're more kind of spread out here, the bigger potential of hail. Also, does determine on, you know, upper level winds, or basically winds moving upwards, or vertical wind shear. But yeah, so that's what we're dealing with here. So that's showing we have a dry atmosphere across the mid levels. This is how high the thunderstorms are going to get here, the red or the yellow line, just under 12 kilometers. So now we determined, okay, we have a lot of instability in the atmosphere. This will allow for thunderstorms to pop off here. Cool. But you have to have your winds at a certain strength here, which we're seeing these winds here at about 20, 30 knots here from the mid-levels of the atmosphere to the surface, which, honestly, from what I've seen, this is actually pretty weak. This is actually pretty weak wind shear. It could still do stuff here. It could still produce storms here, but like I said, you want to see for tornado events, you want to see that scream to the north and this scream to the northeast. So let's go see. I really don't like this sounding here. Yeah, this hodograph is a little bit weird. But this hodograph basically just overlaps the whole entire wind side of things. Let's go see. Abby says, bye everyone, see you soon. See you later, Abby. Thank you so much for joining. Okay, so that's what we're looking at, you guys. So at the surface here, let's see what we're dealing with. So we have northeasterly winds pointing at a long line. So that is at 10 knots. So that's around 10 or 10, 11, 12 miles per hour. That's really kind of slow moving, which is kind of a strike one for tornadoes. And it's moving to the northeast. Like I said, it's best if you want to see it moving to the north. You know, it really just depends, but you can still see tornadoes if it still moves this direction. But like I said, the wind shear is weak. I don't expect any tornadoes out of this. So then we move into the middle portion of the atmosphere. Okay, we have a little bit more of an increase. We have 3 long lines here and then 1 half line. I gotta draw that way better here. So that's 35 knots, but it's still pointing in the same direction here. Okay, still pointing in the same direction here. Go way up in the atmosphere here, same direction. So all the winds are moving in the exact same direction here. What's going on here? 60 knots. So what we're seeing here is that as you go up in the atmosphere, like I said, this is the surface, mid-levels of the atmosphere, upper levels. So what we're seeing here is that as you go from the surface all the way up to the upper levels of the atmosphere, the wind direction does not change, which for tornadoes, you need it to change, okay, most of the time. So that's what we have going on here. So it's all moving in the same direction, but we also see that the wind speed does increase as you go up in height. That's pretty common. That's usually what goes on here. Antonio says more weather updates. I'm basically just explaining, you know, the simple portion of the soundings here, kind of, because I kind of want you guys to understand these so we can look through these together in regard to things. So that's what we're seeing here. So our wind shear is a bit weak here towards the surface. It's all pushing its way here. Like I said, this is the top of the thunderstorm here. It's all moving its way to the northeast. So tornadoes, like I said, you really want to see it pointing to the north here and eventually changing to the northeast pretty fast at the surface too. But we're not seeing it. We're seeing very, very slow wind shear at the surface. So, and it's moving northeasterly. So tornadoes, I really don't see a big concern here with this. I don't think tornadoes are going to be a concern, but like I said, we have a dry atmosphere here. Hail could be a concern. We're seeing decape. This is basically downdraft energy. So values over 600, I say really any values over 400 or 500 is supportive of, you know, producing damaging winds. We're seeing double that at 1200. That's a big deal. That's seeing potentially wind gusts here of 70 to 80 miles per hour. It's around the value of about that. That's a pretty strong wind shear. That's your downdraft. Once all that air must come down, so smacks the ground, spreads out in all direction. That's your damaging winds. So that's what we're talking about, you guys. Like I said, pretty simple, and obviously there's a lot more to this. We just looked at this top, so hopefully you guys learned something new today. I just kind of wanted to discuss this. So we're gonna make a video on this eventually in regard to the parts of the soundings here, and explaining what all these stuff means, and we're gonna look at this here. So for this system, what I've seen, what we looked at here, hail and damaging winds are going to be concerned. Tornadoes not so much. When is the next tornado warning happening? Obviously we can't tell you that, but there is still a chance for tornadoes today, but it's kind of dwindling out. Right now, there's none active at the moment. What's the ML cape on that sounding? Well, mixed layer cape, that's what we're looking at here now. Basically takes the... Okay, so mixed layer cape, that's what we're looking at here. We're seeing that energy, remember, between that blue dotted line and that red line? We're looking at the energy value and accumulation here from the surface all the way up to the upper levels. So mixed layer, or mean layer, same thing basically. That's showing you... we have values here over 2,000. Near 2,500 according to this model. Now, you can have severe weather in anything over 400, I believe. I've seen tornadoes in 500. But yeah, you can have severe weather with low instability. And the thing is, just a little bit of a hint for you guys, the faster the winds, the more stronger wind shear you have, the essentially the lower cape you can have for severity to kick off. So, but obviously if you have a lot of instability, a lot of mixed layer cape, a lot of that, instability from the surface to the upper levels, and you have a lot of wind shear, that's the big days. That's those big tornado outbreak days. Especially if everything is in line here. Okay. So that's what we're looking at, you guys. I don't really want to talk about it anymore because I don't really want to fill you guys' mind too much with this and get you all confused if you're probably not already. But like I said, you guys, I hope you all learned something new here. you know, we're seeing a possible scenario here for April 5th, so we'll discuss this here tomorrow. I'll make a video on it tomorrow, y'all. But anyways, guys, I think that's going to go ahead and wrap up the live stream here for today. Looks like a classic derecho with embedded hail. We could see some hail and damaging winds. It looks like a big concern. But anyways, guys, I think I'm going to go ahead and call it a live stream for the night here. Like I said, we have no active warnings anymore, except for special marine warnings. Nothing too crazy. But yeah, that's basically what we are dealing with here at the moment. Nothing too crazy is going on here. So we're going to go ahead and call it a live stream here for tonight. It's getting pretty late here. Hope you guys enjoyed it. If you guys did, make sure you leave a thumbs up and don't forget to subscribe. If you guys do want to support the channel, we have a link in the description, as well as this pinned in the chat. If you guys want to help us out. We're trying to save up for a new computer because mine's about to blow. It's already been cutting out. It cut out yesterday's live stream. That's how we had to end it. I didn't hit the end button. My computer literally died, and I had to revive it. So, it is what it is. But thank you all so much for being here. You guys are the best here. I really do appreciate all your support, guys. Thank you so much. Good night, be safe, says Antonio. Weather and Go says, yeah, thanks, man. Very, very welcome. Got to be here for you guys. Like I said, I hope that you guys learned something here. Alright, guys, it's going to go ahead and wrap it up for the live stream here for today. Like I said, thank you guys so much for joining us. Going to move this out of the way here. We'll be talking to you guys tomorrow. I'll be making a video here tomorrow, as well as going live as well. Anyways, guys, thank you all so much for watching. Take care, y'all. Have a wonderful rest of your day. Or rest of your night here, evening. I'll catch you guys in the next one. Take care, guys. See you tomorrow.
Breezy. Saturday, sunny. Highs in the lower 50s. Sunday, partly cloudy. Lows around 40. Highs in the mid-50s. Monday, partly cloudy. Lows in the lower 30s.